Hey everybody, welcome back to the Hard4Games channel. I'm your host Tony, and today we have the Intelligent Systems CGB or Game Boy Color emulator. It is a device designed for debugging, emulation, flashing, and ultimately the creation of Game Boy Color and Game Boy Advance titles. Now again, the CGB stands for Game Boy Color, so I was pleasantly surprised to learn that at the time, Intelligent Systems had the foresight to make this forward compatible with the Game Boy Advance. In fact, it even says it's compatible on the back here. Now, you've probably heard of Intelligent Systems as a second-party Nintendo developer. They've done WarioWare, they're probably most famous for Paper Mario, but they've also created a plethora of development tools and hardware utilized by Nintendo themselves and also their third-party developers. Big thank you to Gaming Legend 64 for sending all of this stuff over. We have so much to go over today, a bunch of dev hardware and the elusive silver and teal Space World era variant prototype of the Game Boy Advance. I believe I've looked at the rest of them and showcased them on the channel. I think I've shown them all at this point. I think this is the last one. Either way, he nearly gave me a heart attack by sending all of this stuff over because it has about 10K worth of value, and when all connected and put together, it creates the most anxiety-inducing image of cords you've ever seen. Now let's start with talking about the main emulator unit. Now obviously this is work hardware, so it wasn't designed to be aesthetically pleasing like something you would see at retail. It's designed to be functional, although I still think it's beautiful. On the front, we have our indicator lights and our cartridge inputs. This would be for a more normal style of cartridge, and this we would connect a ribbon cable to that would go to our probe unit. Our probe units are these pieces of hardware right here, these cartridges that you see connected to these Game Boys and also this Wide Boy back here. It's an interface between the unit and the Game Boy Color or the Game Boy Advance. Now here are our different dev units and probes, starting with the Game Boy Color. As you can see here, it has wired power coming from the probe itself and linking down to where the power supply would be. Now, if you were working on Game Boy titles, you wouldn't want to be constrained by battery life. So the emulator unit itself supplies the power to the probe, which supplies the power to the hardware, the Game Boy Color in this case. I should note that this particular Game Boy Color was modded to be compatible with the probe. The wiring was actually added later, whereas the Game Boy Advances I'm about to show you are true prototypes that were originally wired. Now on this yellow Game Boy Advance, or if you're watching this part right here with the Wide Boy, you have a more traditional looking Game Boy Advance probe. This piece of hardware you've probably seen a number of times on the channel. And connected to it is also a save board. This literally means that you can save your game. You can't save your game without it. These come in various sizes. This particular one is 1 megabyte, but it can vary. Interestingly, and appropriately paired with the older Space World prototype Game Boy Advance, we have an earlier version of a probe, which fits into a cartridge. It still has the powered connection here on the back with the wires coming out, but it is a little bit bulkier and a little bit less fragile. Frankly, I prefer this one, although it probably costs more to make because they had to make a shell, but the newer style where it's just sort of a board sticking out of nowhere makes me a little bit nervous. Now on the back here we have our SCSI connections, our dip switches, which will come in handy later, and of course our power. We'll be connecting to a Windows 98 laptop with our programs preloaded. Today we're focusing on the debugger, emulator, and character programs for the GBC GBA. However, I will fully admit that I am not equipped to talk about anything but the hardware and the emulator today. I don't have the knowledge for the debugger, and the gods of the Intelligent Systems company didn't grace this piece of hardware with the Agb or CGB character option. But don't you worry, today we're going to be partnering up with Behind the Code, who will be covering those sections. If you are unfamiliar with Behind the Code, he's kind of like Hard4Games, but way better, and also way more technically knowledgeable, so you should definitely check him out. But before we switch over to him, let's go ahead and take a look at the emulator. Now, I should note that the emulator is compatible with both Game Boy Advance and Game Boy Color, but you will need to have the appropriate unit connected. So for example, even though the GBA is backward compatible with the GBC, the GBA here cannot play Game Boy Color titles. Also, occasionally the unit will lose a connection with a laptop. Note here that all the icons in the program are grayed out. In this case, resetting the laptop does not seem to help at all. We need to use the dip switches to reset the unit. So to do this, you turn 4 to the on position, power on the unit, it'll boot up and then auto shut off. Then you return dip switch 4 back to the original position and power it on like normal, and this reset the connection and seemed to fix the issue. And lastly, for me, because the retro gaming community seems to have an undying fetish for the wide boy, which I simply cannot understand because it is so cumbersome. We're going to showcase the wide boy connected to the emulator unit and playing some games. Now, if you are unfamiliar with what a wide boy CGB or AGB is, essentially it's a Nintendo 64 cartridge that you can put a cart into the cart and play Game Boy games on your N64. And we showcased this before, but just not in tandem with the emulator. So today we're going to be showcasing the emulator receiving a ROM from the computer into the wide boy via the probe into the N64, out to my OSSC, and then captured. So that's what we're showing today. And it's a horrible, horrible mess of cords, even without the capture stuff. It's awful. There must have been a better solution than this, but Intelligent Systems probably was constrained / wanted to work with equipment they kind of already had in-house and Frankenstein some stuff together, and this is what we got. And the retro gaming community has been absolutely drooling ever since. And here is the character program running through the wide boy. I just kind of did this one for kicks. Like I said, Behind the Code is going to explain this a little bit more, but one thing that I thought was pretty cool here is that the Game Boy Advance on screen is the same Game Boy Advance prototype we have here in-house. Okay, so let's go ahead and switch over to Behind the Code for the more nuanced programs. Go ahead and take it away.
Thanks so much, Tony. Thanks for having me back on the show. So today, what are we doing and what are we talking about? Today, I'm going to be talking about the debugger software for this unit, as well as the graphics editing program, that being the character editing software. And that's used for editing textures, sprites, backgrounds, that kind of thing. Before we dive into the control interface and all the software that is used with this unit, I want us to go and take a look at the internal electronics and the main PCBA of this unit. So if we remove the top cover of the emulator unit, you'll see the main PCBA as well as a daughter card for the Game Boy cartridge socket. On the right side, you'll notice a IDC socket connector, and that is used for configuration and programming and testing during development. On the left side of the main PCBA, you'll notice a 72-pin SIMRAM card memory installed. This was actually quite common for equipment used during the 90s. Adjacent to the SIMRAM card, you'll notice a couple of voltage regulators, as well as a 3-volt max cell coin cell battery. This is used to power a 1 megabit RAM chip that's used for configuration. You'll also notice the Game Boy cartridge socket, which is attached to a daughter card. This is referred to as the EMU cartridge adapter 2. The back of the unit has a toggle switch for power. You also have a SCSI ID set of dip switches, and the two SCSI interface ports for connecting to your computer PC or additional hardware. The heart of the system is a Xilinx XC4020XL FPGA chip, as well as a 32 MHz crystal clock, an NEC SCSI controller chip, along with a Nintendo Virtual Boy CPU processor, model number NVC-VUE. This is likely Nintendo repurposing old stock components. We also have a 1 megabit static RAM chip, an 8 megabit sharp flash memory chip, and an Altera Max CPLD for storing the firmware of the system. So now you have the emulator software, the debugger software, as well as the character software packages that were optional to work with both the Color Game Boy system as well as the Game Boy Advanced versions of the hardware, depending on the features that you had enabled. Now, the anime viewer software, that was operational with the Game Boy Advanced as well. It operated with the N64 system using an Intelligent Systems Viewer 64 development cartridge specifically for the Nintendo 64. So for the character software package, you could use this with the emulator unit. However, you could also use it with a development cartridge that Intelligent Systems released called the Agb PIC, or Agb Parallel Interface Cartridge. Between these two pieces of hardware, functionality of the software is the same. However, the Agb PIC was a much cheaper alternative for developers if they were specifically wanting to use the character graphics software. Okay, I'm going to give you guys a very quick preview of how this debugger software works. So this is the Agb Debugger Software. So we'll go ahead and activate that. And this is the window that you see when the software starts. You have a project window here that shows you all of your files that are associated with the project you're working on. You have a source code window to look at different source code files. As well, you have a few different windows here for looking at memory, as well as some of the hardware registers of the Game Boy Advance system. So we're going to look at one of the SDK demos, and it's called the Dolphin Demo. So we're going to go ahead and open that up. And here under the project window, you can see all the source code files that are associated here. So we're going to look at this player.c source code file. And when you open this up, you'll notice all the different functions that are within this source code file. And I have one here that I've set up here with some print messages. So now these conditional statements are for when the player is pressing on the directional pad push buttons. And so when one of the push buttons is executed, we can have a custom message being printed down here on our command window. And this is happening in real time through the emulator unit, through the SCSI cable, and back here to our debugger software. So now what I'm going to do is insert a breakpoint, and we do that by double clicking on this line of code, and we can do this anywhere in our code within the game loop. And what the breakpoint does is it will actually halt the game from running on the system and allow us to go in and monitor and look at some of the memory information or the register information. So now if we run this, so we'll go ahead and build this. We're going to compile all this code. And as you can see down here, it shows you all that process. And then the completed stage, it shows you a dolphin.elf file, which is our compiled ROM file with debug information, and we also have a binary version of that compiled file if we wanted to use it for a different platform. So now if we go ahead and run this, we can do that by hitting F9. As you can see, the Game Boy Advanced unit is running the ROM. So now as we press left and right, down, you can see those debug messages being printed on the command window. Now if I press the up button on the directional pad, you'll notice that the game actually has halted, and it has essentially paused the game, and it's allowing us to go and monitor some of the information within our registers or any other area of memory. You'll also notice that the breakpoint line has changed color. This is just to let you know that it has been reached, and you're able to go in and monitor and check some of the register information. So that's pretty much the basics of the debugger software. And there's lots of different functions and different features that this software provides. But this is just some of the very, very basic features that developers would be using when they're debugging a game. Okay, so we'll go ahead and open up the character software. This is for doing graphics on the Game Boy Advanced. Okay, so here we go. Now, this is a project that I had set up beforehand. So when you're working with this software, you have these texture files that are referred to as character files. And essentially these are graphics that are stored within ROM memory. And now for this demo that I have here, I just sort of slapped together some graphics that I had found on file. However, in reality, a lot of the time developers would cram all of their graphics in as tightly together as possible just to maximize the use of memory in the ROM space. But again, this is just for demonstration purposes. So essentially what we're doing with these texture files or these character files is we're using areas of the graphics within this file and just copying and pasting and creating elaborate background images or object files, which are essentially frames as part of animation sequences. So if we open up a background file, so this background file here that I have, they're referred to as screens. And as you can see here, I've copied and pasted this little area of the texture graphic over and over again multiple times to create this background. And so now if we were to preview this, we would just hit View, Preview Settings, and we could set up our background that we want to preview. And you have a little window here that shows you your memory map of where that information is within VRAM. You can designate and choose which background files you want to preview, as well as some of the palette information. So now if we go ahead and hit this button here for preview, on the hardware, it's going to stream this information in real time over to the Game Boy Advance system, whether it's on the emulator unit or the parallel cartridge. And so as you can see, we have the graphic being displayed. And so now, if I reference a graphic from the texture character file and just copy that, and if I paste it directly onto this background, so as you can see, as I move this around, it's being relayed onto the Game Boy Advanced handheld in real time. Now, developers also would create object files or frames and would do this in the same way, and they were able to make changes to each frame and then add those together as part of an animation sequence. So that's what this software was used for. And so here's another cool graphic that we can take a look at on our Game Boy Advanced. So I'm sure all of you recognize this graphic. Anyhow, it's a pretty cool little software package, and it allowed some sophisticated editing of graphics for backgrounds and also for animation sequences. So it's pretty cool. So that's your basic overview of the Intelligent Systems Agb Debugger Software and the Agb character software for doing graphics. So hopefully you guys enjoyed that and found it interesting. And I will pass it back to Tony.
So once again, a big thank you to Behind the Code for joining me today. Make sure to check him out. I'm going to put links to his Twitter and YouTube account in the description below. He has a ton of different projects going on. And again, if you are really into the dev hardware side of things, like real technical nitty gritty, this is a very good channel for you. And even if you're not, just want to learn what you can learn, jump in, because seeing some of this hardware is absolutely fascinating. And of course, also thank you to Gaming Legend 64 for sending all of this over. Really appreciate it. And if you guys like content like this, make sure to subscribe, hit that notification bell, join us on Patreon if you feel so inclined, and aside from that, we'll see you all later.
Baby, come home. They're hard for games. Baby,